Alright, so in this video we'll turn this giant leg made out of rocks into a Gaussian Splat using a $200 drone, the DJI Neo 2. It's my first time using this drone to create a 3D GS, and I hope it performs well because it's so easy to pack and use. Also, stick around until the end of the video to see how I will convert the 3D GS into a video game asset. Let's get started. A few weeks ago, I had a problem taking off with my drone because I live near an airport, but with the latest updates I should be good to go. I'll double check everything just in case. Time to pack my gear and go find a real life model to recreate it in 3D. I usually use the DJI Mini 5 Pro for this kind of work, but the Neo 2 is so easy to pack that I barely use my Mini 5 Pro anymore. I'll bring both just in case. I only have one battery with my Neo 2, so the model has to be small enough to record all around it, but also big enough to make it worth it to use a drone. There's a park out here in Montreal with giant legs made out of rocks. I used to go there as a child and they looked pretty big back then, so hopefully they work out for this test. It was a perfect day for Gaussian splatting because of the clouds to make sure there's no baked lighting on the model. Rocks are a great texture for photogrammetry and Gaussian splatting, so this might give a better chance for the DJI Neo 2 half-inch camera to recreate it. There was a lot of people at the park and I didn't want to bother them with the drone, so I made it quick. The battery only lasts 10 minutes anyways. It was my first time flying the Neo 2 manually from my phone, and it's a lot harder than I expected with those virtual joysticks. They're very sensitive, so I did as best as I could. I tried to film the model from every angle and as slow as possible, but yeah, the controls are hard to grasp at first. My video settings are 4K and 60 frames per second. Unfortunately, when using the phone as controls, these are basically the only settings you can change. White balance, shutter speed, and other advanced options are only available when using a remote control. Once I was done, I packed my stuff and went back home to start the Gaussian Splat process. So once we have our footage, it's time to trim it and only keep the good stuff. I'll remove the beginning of the clip when the drone takes off and also extract 5 frames per second using ffmpeg. 60 frames per second make sure the images extracted won't be blurred, but we don't need that many frames to recreate the model. 5 per second will be plenty. I'm on Linux right now, but you can easily do this on Windows as well. Just install ffmpeg and use the same command. Once the process is done, I have a bit under 1000 frames and now it's time to load them into colmap. Now this is where the fun part starts. We're going to reconstruct the model in colmap. At the end of this part, we will know right away if we can get a good Gaussian splat out of the dataset. So the first step is to install colmap, which you can get from their GitHub. Once you have colmap installed and loaded, it's time to create a new project and save your database. Select the folder with your frames inside and click Save. The first step is to extract the features from the images. These are contrasted points in each frames that colmap will try to match between each frames in the next step. When the extraction is done, it's time to match the features. I'm using sequential here since all the images come from a video. When the feature matching is done, I will reconstruct the model. This is a nice part to watch. You'll see where the drone was in spatial location for every frame that we extracted earlier. This step might take a while depending on your computer. It took way longer than I expected, but the results look promising. Let's start the Gaussian training. So you'll need to build from source Lichtfeld Studio to locally create the Gaussian Splat. I explain how to do this in a more in-depth video, the link will be in the description. Once you have it installed and opened, make sure your folders are properly named and in the right directory. You want all your frames in the images folder and in the same parent directory as the colmap model, which should be named sparse. Drag and drop the parent folder in Lichtfeld Studio and load the dataset. From there, you will have to click the GUT checkbox to undistort your images, and you might want to lower the number of iterations and Gaussian for your first run. Click Start Training and see the magic happen. Once the Gaussian training is done or when you're satisfied with the results, you can export the PLY file. You can also trim everything around your model depending on your project. Here I'll remove everything around it just to keep the foot. It's quite easy to do in Lichtfeld Studio, just make sure you don't remove essential Gaussians that will remove details from your model. Converting a Gaussian splat into a video game asset can be challenging, and that's where today's sponsor, Neural 4D, comes in. Neural 4D is an AI-powered 3D content generation tool. It's designed to help 3D artists quickly transform ideas into high-quality 3D models, but without starting from an empty Blender file. There are different ways to use Neural 4D for this workflow, like generating from a single image or using the multi-view feature with multiple angles of your model. But my preferred method is Neural 4D 2.0, which is currently in alpha, but I'm already getting great results with it. I simply upload a screenshot from the Lichtfeld Studio viewport, add a description of what I want to create, and let Neural 4D generate the asset. Once the model is ready, I can download it, test it in my game engine, and make adjustments if needed. It's a great way to prototype assets and bring 3D ideas to life. Check out Neural 4D at neural4d.com. So here you have it, a full process of creating a Gaussian splat with a low-budget drone. I'm quite impressed with the results and won't be shy to use the DJI Neo 2 again for a similar project. Thanks for watching. See ya!